Okay, let's talk about how servos work. Servos are great for moving things on your robot. Originally, they were designed for controlling the control surfaces on RC aircraft and steering and things like that on radio-controlled cars. But they're used in lots of other applications now, mainly because they're simple to control and they offer really precise control or position of their output shaft. The base PCB on the robot can support up to 16 servos, so it's useful to know how they work. Depending on how much speed or how much torque you need, there's a wide variety of servos are available, from these nano and mini size all the way up to regular and even larger size servos that are shown in this picture. Inside the servo motor, take a look at this picture. There's a DC motor with a gearbox for slowing the motor down and giving you a lot more torque. There's a control board, and that control board connects to the motor, and it also connects to this potentiometer. Potentiometer is like an analog volume control, and the shaft of that potentiometer connects to the output shaft of the servo, and that allows the control board to monitor the exact position of the servo's output shaft and control the motor to keep it in that position. This thing on the output shaft of the servo motor is called the horn, and servos typically come with a variety of sizes and shapes of horn to suit your application. The shaft is splined, so you can snap that horn on in several different positions to help you center the servo. Regardless of the size of the servo, they always have the same 3-pin connector. Those 3 signals, or the 3 pins, are power, which is usually 5 to 6 volts, ground, and then there's a signal that you send to the servo to set its position. The power pin is always the middle pin. In this case, it's shown as red on these 3 connectors here. The ground is always brown or black, and then the signal is the opposite side, usually white or yellow or orange. Here's a picture of the base PCB, and the 16 servo ports are along the bottom edge here in this picture, labeled 0 through 15. The ground pin on the servo, so like this pin right here, would connect to the bottom row. So these 16 servo ports are in 16 columns. So you'd plug the servos in, 0 here, 1, 2, and so on. So the middle pin is 5 volts, and the upper pin are the 16 signal pins that are being output from the baseboard into the servo. It doesn't matter if you plug the servo in backwards, it won't damage it, so you don't have to worry about that. So let's look at how the servo its position is actually set, how it's controlled. Let's draw a picture here of a graph. So on the hat board is this chip right here, is the servo control chip, and really all it does is send out a series of pulses to the 16 pins. So to control a servo, we just need to send it a pulse every 20 milliseconds. So if we draw a graph of time and voltage, the servos take a control signal between 3.3 and 5 volts. And you have to send them a pulse every 20 milliseconds. So every 20 milliseconds you send a pulse. And when the servo receives that pulse, it measures so this length of time is 20 milliseconds. And every time the servo receives a pulse, it measures the length of the pulse. So typically, this pulse is in the range of 1 millisecond to 2 milliseconds. If the pulse is 1 millisecond long, the servo will move all the way to one direction. Most servos are set or the standard servo is has a control range of 90 degrees. So if you send the servo a 1 millisecond pulse, it will move all the way to one extreme. If you send it a 2 millisecond pulse, it'll move all the way to the other extreme, 90 degrees. So if you send it a 1.5 millisecond pulse, it'll go to its middle point. Pretty straightforward, but not all servos are identical. So this is kind of, this is typical, but it's not necessarily the case for all servos. For example, some servos will move 200 and up to 270 degrees. A lot are capable of going just 180 degrees, and some can even accept pulses outside of this 1 to 2 millisecond range. For example, I have a 270 degree servo on my robot right now that'll take pulses from 0.4 milliseconds to 2.6 milliseconds. And I have a 180 degree servo that will take pulses in the same range but map that pulse length to a range of 0 to 180. So it's important to know how this works, because in the next video I'm going to show you how we can go into the code and modify a servo settings file to specify how we will send pulses to each of these ports. So for each port on the baseboard, you can specify the minimum pulse length and the maximum pulse length that servo will receive. And depending on the servo that you have plugged into that port, you may need to tweak those max and min pulse lengths to get the full range out of your servo.